So now let's go on to the next step. In section 2.8, we see how to graph linear and absolute value inequalities. So before we're doing equations, now it's inequalities. So we're going to be dealing with, greater than, less than, or equal to, and so on. All right, so let's go ahead and look at your slides. So slide number 12 in this section, if you notice, it's asking you to graph something that we've already practiced, so move, of course, your x this way, divide both sides by -2, which is what they do here. However, they do test a point first to see, well, I know the graph of x minus 2y is equal to 4 is here, but, where is it, where's it, you need to shade the region where you're referring to. And so we need to test to see if I put a particular point such as 0, 0. So is 0, 0 a part of the solution? If it is, then you would shade it. And it turns out that when you substitute 0 and 0 for x and the y, then 0 is less than 4. That's true. So therefore, that is a point in the region you're looking for. So you shade the top. If 0, 0 would have turned out false, like it doesn't work, then that means that that point is not in the solution, so you would have shaded the other side. So these are some examples for you to kind of look at and see how you set your boundaries, where do you shade, and so on and so forth. Normally you just plug in a point, and usually 0, 0 works out really nice because if you plug that in and it's part of the solution, then you shade that area, and it's small numbers compared to, imagine here plugging in something like huge, like 800. And so on and so forth. So then the same thing goes with the absolute value inequality. Now, instead of here's your V, and see, I already see a transformation like we spoke about in previous section where you have the -2. So if you notice, the V, instead of being at 0, moved down 2 on the y-intercept. And so here's your new inequality. But the question now is, where is y greater than or equal to the absolute value of x minus 2? We'll test a point. Notice how they tested 0, 0 again. And so once you plug in 0 for x, 0 for y, you find out that 0 is greater than or equal to -2. Yes, 0 is bigger than -2. And so therefore this is true. So 0, 0 is a point in the area I'm looking for. So then you shade this top part where the 0, 0 is found. So then here's some practice problems to see if you can do that on your own again, and the answers are there, so that way you can check yourself. Same thing with the study guide and intervention section. Here you're going to be looking at different equations, and remember, treat it first like an equal sign. So kind of ignore that, try to graph that. So for example, to graph this, you need to turn it into slope-intercept form. Makes it a little bit easier. That way this is where it crosses the y-axis, that's your B. So here is crossing at 2, and your slope is -1/2, so it's a line that goes down to the right, and the step is you go down 1 over 2, down 1 over 2, down 1 over 2, like a step, and that gets you that equation. Now the question is, well, it wasn't an equal sign. There's this greater than sign here. So test a point, 0, 0. There it is again. So if 0, 0 makes it true, then you shade this part. So let's see what happened when we insert that 0 for the x, 0 for the y. Oh, wait a minute. I get 0 greater than 4. No, that's completely false. So therefore, this point, 0, 0, is not in the graph. So I don't shade this area. You shade the top. So graph the rest of the inequalities and see what they look like, and then decide, plug in your 0, 0 to see which one of these makes it true. Then you've got a little additional practice here now with the absolute value as well. And so go ahead and do some of those to see how it goes with the inequality.